Hello and welcome to the App Inventor Food Chase tutorial video. In this tutorial, we'll be making a food chase app where you control a ball and use it to chase food, all while trying to avoid another ball that will end the game. In this one, you'll be learning a lot of new and cool concepts, such as procedures, if statements, and sprites. So let me show you the finished product of what you'll be making. This will be the completed food chase app. As you can see, there's 4 pieces of food that you can catch. There's a green ball that moves randomly around and bounces off the edges, and there's the red ball down here that you can fling about. Alright, now I've played a little bit of the game to make the ball a little bit bigger. As you can see, if you bring it around, it's going to eat food. Now let's get it to hit the green ball. If it hits the green ball, the game over sign comes up. If you press the yes button, then it resets. If you press no, then it closes the app entirely. Go ahead and download the AA file in the description of this video. This will be the template that we'll be working from. Once you've downloaded it, go on to this App Inventor page and upload it. To do this, go to My Projects and Import Project from my computer. Click on it and choose the file you've just downloaded. It should open automatically. This is the main screen of the Food Chase template. As you can see, we don't have any components, but we have included a few media files. The rest we're going to do here in this tutorial. To drag a ball around the screen, you're actually going to need to draw it around a canvas. So we need to drag in a canvas first. To get a canvas, click on the Drawing and Animation drawer and click and drag a canvas in. As you can see, it's really small right now, and since we're going to want to drag the ball all around it, we want to make it as big as possible. Go to Components, click on Canvas, and check out its properties. We're going to set its height to fill parent and its width to fill parent. This makes both the height and width as large as possible and the size of the screen, which is what we want. Now we're going to want 2 balls and 4 pieces of food. We can drag in the balls from here. You can drag them in anywhere. And the 4 pieces of food will be image sprites. Image sprites are basically the same as balls, except that image sprites, you can include a specific image to it, and balls will always be circular. Let's drag in 4 image sprites for the 4 pieces of food. Now, it's always best practices to rename all of these components so that you can recognize what they are. So let's call one of the balls the red ball. Press OK. Go to the next ball, press rename. Let's call this one green ball. And for all 4 of these sprites, then there'll be food. We're going to name them Food 1, Food 2, Food 3, and Food 4. Go ahead and do that. All right. Let's take a look at some of the properties of these sprites to get you familiar with them. Here you can see the heading. Heading is the direction that the image sprite will be facing. It goes from 0 to 360 degrees in a circle around it. The width and height can be changed to resize your sprite, just like we did for the canvas. The interval is how often the image sprite moves. Interval is set in milliseconds, so 100 means it'll move every 1/10 of a second, and 1000 means every second. Picture can be set to upload an image file to your project. Speed is how fast the image sprite moves each interval. Right now, it has no speed at all. We're going to want the rotation to be checked. and that means the image sprite rotates according to its heading. X and Y are the positions of the image sprite on the screen. We won't be using Z in this case. For the balls, they're basically the same as the food, since they're both sprites, but they have two different components. Here is the paint color, and this actually changes the color of the ball. So since it's black, right now the ball is black. Also, we have the radius. The radius is the size of the ball. Right now it's at 5, but we can change that. Now let's actually set the properties for each of these components. Click on red ball. First, we want to make it a little bit smaller, so let's set its radius to 2. And of course, since the ball is red, let's set its color to red. Now we can do the same thing with green. Set its radius to 2, and we'll set, of course, its color to green, so we can tell them apart. For the foods, we're going to change their sizes to 30 by 30 pixels. This will standardize their size. And since we want them to actually look like food, we're going to set their picture to some of the imported images we've given you. I'll set it to red. And let's do that for the rest of the foods and give each of them a different food image. As you can see, I'm going to be going through each of the 4 foods and changing their height, width, and image of the sprite. That way we've standardized the dimensions and made sure that they all have different images to keep the food variation. Go ahead and do that, and feel free to refer to this video as you do. All right, you've set the properties for these, but we still need to set the properties for the screen. Hopefully, these will already have been checked, but make sure that you have these components set. First, we need to set the screen orientation to portrait. You can do it by scrolling down here and make sure that you're set to portrait. Next, make sure that the scrollable box is not checked. Make sure that it stays unchecked. And finally, set the sizing to responsive. This will set the sizing according to your device screen. The last component that we'll need is a notifier. You can get it from the user interface section. Click and drag it in. You'll notice that it doesn't show up on the screen, but actually shows up under non-visible components. This is because the notifier is a notification box that will show up under certain conditions, but doesn't show up initially. We'll be using it later. Now, it's time to go on to the block section so that we can actually code some of the functionality. To do that, go to the upper right-hand corner and click on blocks. All right, what's the first functionality that we want to code? Well, we want it so that when you drag your fingers across the screen, then the red ball will move in that direction. You can do this by going to the canvas blocks and doing when canvas1.flung. Now, you might be wondering why we're not doing when the red ball is flung, and that would technically also work, but the red ball is so small that it's pretty unlikely that your fingers would reach exactly that, so just having the canvas being able to fling gives you a little bit more leeway. So when the canvas is flung, you want the red ball to move in the same speed and direction that you flung the canvas. So we need to change its speed and its heading, which is the same meaning as direction. You can go into the red ball section and find set red ball.heading and set red ball.speed just below it. Let's put them in. Now, what do you want to set the heading and speed of the red ball to? Well, you want it to set it to the same number you set the canvas flinging to. And these are both available right here if you just hover over the word speed and heading. Hover over heading, drag out get heading, and put it in. Same thing for speed. And there you go. You've set the red ball speed and heading to the same speed and heading that you flung the canvas at. Go ahead and try and test out your app now, and make sure that the red ball will move as you fling across the screen. You can test it by going to Connect, AI Companion, and go ahead and scan this with your companion app. To take a look a little bit closer, I increased the size of the ball so that you can see it better for this demo. Don't expect it to be this big when you actually make it. But here, you can swipe the screen and fling the ball around in any different direction. All right, now we can go on to the next part. If you've gotten the red ball movement to work, let's go on to collisions. The red ball could either collide with a green ball or with a piece of food. If it collides with the green ball, then the game should end. So let's take a look. Here, you have the when red ball collided with. This is good. This will check if the red ball has collided with something. And the other block is what it has collided with, either the green ball or the pieces of food. So we need a specific if statement to check what it has collided with. You can get this from control, and we're going to want an if, then, else block. If the red ball has collided with the green ball, then we end the game. Otherwise, we know it's collided with food, so let's make it bigger. To check if it has collided with the green ball, we're going to need a logic. We need to check if the thing the red ball has collided with, the other, is the green ball. You can get the green ball from just going straight to the green ball drawer and getting the very bottom block. So if the thing the red ball has collided with is the green ball, well, then the game is over. And we're going to use the notifier to let you know of that. Go to the notifier drawer here and choose Show Message Dialog. This will give a pop-up of a dialog. This Choose dialog will show that the game is over. So we're going to want some text to explain it. First, we can have the message say, you collided with green ball. Play again. The title of the notifier can just say game over. And you have the option to either yes, play again, or choose not to. So we can have button 1 be yes, you want to play again, and button 2 be no. And let's set cancelable to be false. That way the user can't just dismiss this without making a choice at all. All right, so what about the else statement here? Well, if it hasn't collided with the green ball, then it's definitely collided with a piece of food. So we want the piece of food that got collided with to move to a different random location, and we want the red ball to get a little bit bigger because it ate the food. So we're going to want to move the piece of food. But how do we know which piece of food just got collided with? It's not really possible to know. There's nothing in here that has the name of any of the food sprites. So we could, for example, do a bunch of if statements and say, okay, if the other is food 1, then change the position of food 1. And if the other is food 2, change the position of food 2. But that would take a really long time and involve a lot of copied blocks. It turns out there's a faster way to do this. If you scroll all the way down and go to any component, you can see that there's a drawer called Any Image Sprite. This is good because all the foods are of type image sprite, and so it doesn't matter exactly which one you want. So we can do call image sprite.move2. This will move the image sprite. The for component blocks asks, which image sprite do you want to move? Well, we want it to be whichever one the red ball collided with. So again, this other block. And we want it to move to a random X, Y location on the screen. To get some randomness, and let's pull out a random integer from 1 to 100 here. Now let's think about what the X component of the image sprite could be. The X component is the horizontal position of the sprite. And it could be a very small number, it could be 1, but we want the maximum value of it to be not 100, but something close to the width of the screen. So it can't go past the width of the screen, but it's not that much less either. So you might think that all you need is just the canvas.width component. Just putting that right in here. And you'd be partially right, except you also have to take into account the width of the image sprite, because that's added on top. So if you went all the way to the canvas width, part of the image sprite might get cut off. So you actually have to take the canvas width and subtract the image sprite width. We can do this with a subtraction block. Take the canvas width and subtract the width of the image sprite. So we can go back to image sprite. This will be the any image sprite. And we can do image sprite.width. And again, it's asking which image sprite? Well, it's the one it got collided with. Then we can put that in. And as you can see, the X component, the horizontal component, will be some random number between 1 and the width of the screen minus the width of the image sprite. We can do something very similar for the Y component, which is the horizontal up-down position. We can right-click on this, press duplicate, and of course, instead of the width, we're going to want to do the height, the canvas height, and the image sprite height. This is great. This sets up the movement of all 4 food components without needing to copy and paste. Because the red ball has eaten the food, we want to increase its radius. Let's increase it by 2. You can get the red ball and click on the red ball dot radius. And we're going to increase it by 2. So we can go into math, get a plus sign, go back into math, get a number. Let's change it to 2. And always we want to set the new radius to be the previous radius plus 2. So to get the previous radius, you can click on red ball, go get its radius, and there we go. To make things interesting, let's also increase the size of the green ball so that it gets harder every time you eat a food. To do this, we can duplicate, put it right below, and change to green ball. And let's only increase it by 1 this time. Now we're going to set up a piece of code that's going to be used in 2 places. These are the blocks that will restart or reset the app. So it will put all the food and the balls in a random place, and it will reset the radiuses of the 2 balls. Now, this will be used in 2 places. Once, when the app is started for the very first time, when it's initialized, and again, anytime that the game ends and the user chooses to play again. Because this is going to be used in multiple places, we could just make the code twice or duplicate it and put it in both times, but because this is going to be a lot of blocks, it's pretty unwieldy. it's a better idea to instead use a procedure. A procedure is a special wrapper that can have the pieces of code in it, and then you can call it in many different places and just use a single call procedure block. It's a lot faster and cleaner, and you'll see it in practice soon. Let's call the procedure restart. And when we want to restart, we want to put all the sprites in random locations. So, for example, for food 1, we're going to do call food1.move to a random x and a random y. We've already basically done it up here in the collision. So we can actually copy this. But of course, you see this x here? The restart procedure doesn't know what other is because other isn't defined here. It's only defined in the other part. So we can't use this. Luckily, since we know that we're dealing with food 1, we can just get food 1's width. Great, and for y, we can do basically the same thing, except for height instead. Canvas height, as well as the food height. Now we'll do this for all the other foods, food 2, food 3, and food 4. We can do it very quickly, just by duplicating. This will be food 2 instead. And don't forget to use the food 2 widths and heights. Let me explain why we're using the individual sprite names instead of the AnySprite component like we did in the collisions. In the previous case, we just had to name one sprite that we didn't know the name of. But here, we have to do all 4, and we do know their names. To use the AnySprite component, we would have had to make a for loop. This is a little bit more complicated, and you're welcome to try it out, but for now, we're just going to do all 4 of them explicitly. Okay, great. We also need to place the green ball and the red ball in random positions. This is very similar. There's the red ball dot move to. Because the red ball and the green ball are quite small, we don't actually have to take into account the width and height of them, and instead we can just have it be the flat width and the flat height. So we can duplicate it, but then take out the subtraction. And we'll do it for the height as well. And let's do the same thing for the green ball. Instead of red ball, we'll change this to green ball, but that's the only thing we need to change. Remember, the random number is re-rolled for every single one of these, so they're not going to be the same. You're going to also have to reset the radii of the red ball and green ball because they increase in size around the game as you eat food. Then when you restart, you're going to want to set it back to 2. To do this, you can go into the red ball drawer and go to set red ball dot radius, go into math, and let's get the number 2 to 2. And we'll do this the same for the green ball. Great. Now, if you saw in the test, we don't have the green ball moving yet, so let's do that now. You can duplicate this, and we can set the green ball dot speed to 5. Duplicate again, and we'll set the green ball dot heading. We're going to want to set the green ball heading to a random direction. Remember, randomness, we can get a random integer from 1 to 100. Now, heading is in degrees on a circle, so we can go from 1 to 360. Great. This is the basic setup for the restart procedure. Now, the procedure doesn't actually do anything, but we can now call it, and it will call all of the blocks inside of this procedure. So when do we want to call it? Well, we want to call it when it first starts up, so when the screen is initialized. You can go into screen 1 and do when screen 1 is initialized. What do you want to do? Well, you want to call the restart procedure. Call restart. Great. All right. The other case in which we will want to call restart is when the game ends, when the red ball is hit by the green ball, the notifier comes up, and the user chooses to say yes for the restart. As a quick refresher, here's the block that does this, when the notifier shows a choose dialog. The component that we're going to need now is in the notifier. Click on notifier 1 and do when notifier1.afterChoosing. This block will fire after the notifier has shown the option and the user has chosen a choice. The choice could either be yes or no. We want to restart when the user chooses yes. So we're going to go into logic and get an equal sign. And we need to check if the choice is equal to yes. It could be either yes or no, and we need to check if it's equal to yes. So we can put in an if statement and do if the choice is equal to yes, then, well, we need to restart. So we can do procedures and call restart. Those are the two cases in which we will call this procedure. Okay, now what do we do if the choice is no? Well, if the choice is no, then it's definitely not equal to yes. So we're not going to go into this if statement. So we need to check what happens if it does the other option. For this, we're going to need an else. You can add this directly into the if-then statement by clicking on the blue gear, clicking on the else, and dragging it into the model here. As you can see, it's modified your current block. So if the choice is equal to yes, then you go into the then block. But if it's not equal to yes, that is to say if it's equal to no, then the else block will trigger. Well, what do you want to happen if the user chooses not to restart? You just want to close the app and end the application. You can get that in the control block right over here. Scroll down and go to Close Application. Drag that into the else, and there you go. You've completed the notifier after choosing block. Right now, the green ball just moves in a random direction until it hits the edge of the screen, and then it can't go any further, and it's not going to be doing anything else. We want it to actually bounce when it hits an edge. Luckily, this is mostly built in for us. If you click on the green ball, you can do when green ball.edge reached, and that's when it reaches the edge of a screen. And when the edge is reached, we want the green ball to bounce. So there's a block for this. We can just do call green ball.bounce. The edge is which edge you want it to bounce off of, and well, it's the edge it just hit, which is the one right here. And there we go. Now we should be able to have the green ball move around and bounce, and have a reset whenever the game ends. Go ahead and try it out with the AI companion and make sure that it does all of those things. Alright, as you can see, this is how your app should look like so far. You have the small red ball, which you can fling around. It will be able to eat food. If it touches the piece of food, it gets bigger, and the piece of food moves away randomly. The green ball moves around randomly as well. If the green ball touches the red ball, then the game over notifier comes up. It has the option to either continue the game, or if you, by pressing no, you'll close the app entirely. By pressing yes, it will reset the board randomly and bring all the radii back to the minimum. The next part that we're going to be having is a score function. You can keep a current score of the game that you have, and keep a global high score of all of the games. To do this, we're going to need a few more components, so let's go back to the designer by clicking in the upper right-hand corner. We're going to need 4 labels, and to lay them out, we can put in a horizontal arrangement at the top. This will make sure that the labels are horizontally laid out instead of vertically. Let's set its width to fill parent, so it fills the entire width of the screen, and set its horizontal alignment to center. Next, we can put in our 4 labels. Just go ahead and drop them in. These will be the score labels. The first one we're going to name score label, and its text is just going to have the word score on it. The second one is going to be the actual numerical score. We'll name that one score, and initially the numerical score is going to be 0. So there we go. Label 3 is going to be renamed high score label. And its text is going to be the words high score. And finally, this will be the actual numerical high score. Name it high score, and we'll give it the initial value of 0. Now let's go back to the blocks. To initialize a variable, you can go into the variables section. A variable is a value with a specific name that can be changed throughout all of the blocks if it's global. So we're going to initialize a new global variable. And we're going to set it to be equal to 0 because that's going to be the initial score. Let's call the score high score. All right, we're going to want to update the label of the high score every time that the app is restarted. So we can do, when the screen is initialized, we can set the high score value, so this would be the text component, to the actual value of the high score variable. So you can do get the global high score. This will update it after the screen has been initialized for the first time. Next, we're going to want to update the actual current scores, no longer the high scores anymore. Well, after you restart, the score goes back to 0, right? So let's do that. We can set the score label, just the score, back down to the numerical 0. We also want to increase the score when the red ball has eaten some food. So if we go back to the collided with part, we can set the current score value, set score.text, to the value of the radius, since the radius also goes up every time the red ball eats food. So you can just take the red ball.radius, duplicate it, and put it right here. You might be wondering why for the score, we just gave the label a number directly, but for the high score, we made it first a variable and then gave the variable to the label. App Inventor labels are special in that they can store values just like variables, but in general, if you use other programming languages, you'll be using variables all the time. We're just showing both methods here to be thorough. Now, we want to be able to update the high score. If the current score is higher than the high score, then you need to update the high score to be that value. This means that we're going to need another if statement. You can get that in control. Great. Now we can check if the current score is greater than the high score. You can do this with a mathematical sign and instead of an equals, you're going to want the greater sign. So the high score is going to be just the variable get global high score, and the current score is going to be the label of score, its text component. There we go. If the current score value is greater than the global high score. If it's actually greater, then we're going to want to change the global high score with the set block. We'll set the global high score to the current score dot text. This will update it. To have the value actually show up on screen, you're going to have it show up on the high score label. Here, you can go to high score and do set high score dot text to the global high score value, which you can get from variables. Get global high score. Then it should show up on the screen. Okay, now you can see that if you've collected food, your score should go up. Now, let's hit. The game over sign comes up. And if we restart by pressing yes, and there you have it. You can see that everything is reset, but the high score is now 16, which was the score that we got in our last playthrough. Okay, but if you pressed no for the notifier and reset the app entirely and then reconnected, you can see that the high score is not saved, and it goes back to 0 after this. So we need to fix this problem, and that's where TinyDB comes in. If it works, you should have found that by eating food, you do increase the score. But if you close the app and then try again, your high score isn't saved. Let's add that function now. Go back into the designer, go into storage, and pull out TinyDB. Let's click and drag it in. You'll see it show up under non-visible components along with the notifier. Go back to blocks, and I'll explain what a TinyDB is a little bit more. TinyDB is a component that stores persistent data. So it will keep values even after you've closed the app, and it will save them for when you next open it. This is really useful for saving our high scores so that we can close the app in between games and it'll still keep our great scores. It has two main blocks. Let's take a look at them now. It has the get value and the store value. These are pretty similar to getting and setting variables. The tag component here is the name of the variable. So for example, the name high score. And the value is the actual value of the variable, for example, 0 or 1. So it's very good at saving variables. Let's take a look at it in action. Let's pull out the get value. The tag is going to be the name of the variable stored inside TinyDB. We can set it to be anything we want, as long as we keep it consistent. Let's go into text and call the tag food chase high score. I'm calling it food chase high score instead of just high score because all your App Inventor apps use the same single TinyDB with all tags from all projects stored in it. To prevent conflicts between apps, you want to name it according to the project name, as a convention. This is the default value it will return if it can't find the tag in its database. We want it to return 0 if it can't find it, because if it's never been saved, you haven't played the game yet. Let's put in the number 0. All right, so where do we use this? Well, we use it when the screen is initialized. We want to set the high score to be this food chase high score. So if we go into variables, we can do set global high score to be equal to the value from TinyDB, that's the food chase high score. If it can't get anything, it'll set it to be 0, and then it'll do the component that we did, which is set the high score text, so the part that we can actually see, to be this global high score that we got from the database. But where do we actually save the updated value to the TinyDB so that we can get it later? Well, we do it whenever we update a high score. And we update the high score when the current score is greater than the high score at the end. So we're going to have to set it here. Go back to the TinyDB, and now let's get the store value. We'll put it under. The tag we're going to have to keep consistent. Remember, it was food chase high score. And the value that we're going to want to store is the global high score, which we can get from the variable drawers as usual. Go ahead and test out your app again, and try closing your app at some point and see if it now saves your high score.
And there we go. This is going to be your completed Food Chase app. Congratulations. If you try it out, and even if you close your app, the high score should stay. So if I force close the app, and now if we reconnect and restart the app, you can see that the score went back down to 0, but it preserved the high score. That's the power of TinyDB.
If you've gotten this far, then congratulations. You've completed the Food Chase game. There are lots of options for you to update this game and add even more fun components. For example, you could add some sound bits, some crunching or eating sounds that happen when the ball eats a piece of food. Or you could have the pieces of food move as well to make the game a bit more challenging. You could even make the green ball move faster as time goes by to add even more challenge. Overall, congratulations on completing the tutorial.